Good morning, student. Today we are going to learn about your Hartnell Governor. Okay. So, what is a Hartnell Governor? So, Hartnell Governor is nothing but a spring controlled governor. Okay. So, here you can see the diagram. This is the diagram of a Hartnell Governor. So, these are the balls as you have seen. This is the bell crank lever. Okay, this is a bell crank lever, and as it is a spring control lever, so here inside the frame we have a spring. Okay, so when the ball rotates like this, if the ball is rotating like this or the ball is rotating like this, it is rotating within the fulcrum, and this is the horizontal distance from the fulcrum, from the point O to R is your what? Y. Similarly, from point B, center point of the ball, to point O is your X, vertical distance. Okay, next, this is the spring, and in once again, this is the spindle, this is the nut, frame, ball, and here the ball is rotating. When the ball is in minimum position, here this is the neutral position. If it is rotating with less speed, so ball is moving like this, so it can be seen by this diagram. So ball is in this position. Okay, similarly when it is in maximum position, maximum speed, so it is moving like this, and this is shown by the figure, this one. Okay, this is the minimum position and this is the maximum position. Next we will see the related terms. So R1 is what? R1 is the radius of rotation of ball from the center, ball center from spindle. So here to here is your R1. Similarly, from center distance here to the governor axis is your what? R2. Okay, let it be. Next, here, apart from your weight of the ball and centrifugal force and mass of the sleeve or your, we have one more force, that is your spring force, S1. So here, as in the diagram we have seen, it is, we have two balls, so the mass also is divided into two parts, one half is this side and one half this side. So this one is what? mg by 2, mg plus s1 by 2. Okay, next, s1 s2 is the spring force, m is the mass of the ball, small, and next capital M is the mass of the sleeve, and 1 is the speed of the governor, minimum radius. So it is at minimum radius, and 1 is the speed at maximum, and 2 is the speed. Similarly, corresponding values of angular velocity omega 1 and omega 2. Next is your what? S1 and S2 is your spring force, we have already seen. X and Y. X and Y are what? X is the what? Length of arm, vertical. Okay. Similarly, Y is the horizontal. So this is Y is the horizontal length of arm. Next, R is the distance of the fulcrum from the governor. So what is R? R is the distance of the fulcrum for the governor. So this is O point, fulcrum point, O point. This is your point O. Okay, this is here we have point O. So here to here, a governor axis, the distance is your R. This one is R1, this one is R2. Okay, but this always remains R. This to this. Okay, from O to governor axis, the distance is always R. Next, let h be the height of compression. Okay, so when it is in minimum position, we have the governor is moving like this, and this is the height. And when it is moving in maximum position, it is tilting like this, and this is h2. So in minimum position we have h1 and this one is h2. So what is h? H is here, h is equal to h1 plus h2. So here h is equal to h1 plus your h2. Okay, next. Here you can see this one is your h1 and this one is your h2. Here in your minimum position this one is h1 and this one is your h2, and this whole distance h1 plus your h2 distance is your h. So here we are writing h1 is equal to h is equal to h1 plus h2. Okay, now for minimum position, that is when the radius of rotation changes from r1 to r as shown in figure A, the compression of the spring or lift of the spring h1 is given by what? So when minimum position, so see, we will see this is the minimum position when there is a compression of spring, and h1 is given by what? H1 is shown by what? So you will see what is h1 here. So in this diagram, see h1, since this triangle is similar to this triangle, so we can write down h1, that means this distance divided by this distance. So this distance is what? Y, and this distance is what? X. Okay, as I have shown you in here in this diagram. So the distance of the fulcrum to the roller, these are the two rollers in which this fulcrum is rotating. So arms are rotating. So this to this is y, and from this to this is x. So h1 by this distance, I mark this point as red. So h1 by y equal to your, this distance is what? A1 by your what? X. So A1 by x. So this can be written as what? See here in this diagram, what is A1? A1 is nothing but r minus r1. So I can write down here, in place of A1 I can write down r minus r1. Okay, similarly for maximum position, okay, that is, so for maximum position your h2, that means this is your h2. So what is h2? H2 is nothing but h2, this distance divided by this distance. So this one is y once again. So h2 by y equal to what? This one is a2 by x, this is x. So a2 by x. Now see once again this one, what is a2? A2 is nothing but r2 minus r. So in place of a2 I can write down r2 minus r divided by x. So now this one is as equation 1 and this one is equation 2. So adding equation 1 and 2, we have what? h1 plus h2 divided by y is, so I'm taking this total, and this one is what? r minus r1. Here is also x, here is also x, so I am doing this as x plus this one r plus r2 minus r. So here this is minus r and this is plus r. So what we are getting, r2 minus r1 divided x. So h1 plus h2 is nothing but what? H by y is equal to r2 minus r1 by x, or you can write this as h equal to r2 minus r1 into y by x. Okay, this is the equation. Now for minimum position taking moment at point O, so we are writing now for minimum position taking moment about point O, we have what? So in minimum position we are taking moment at point O. So when we are taking moment at point O, see this diagram. So this is the O point. So what are the forces here? This force, and this force. For this force, this is the force vertically acting. So distance will be horizon from where to where? From the force where it is acting to the distance where the moment is taken. So this distance, horizontal distance, so this one is what? This one is nothing but your y1. Okay, so next here this one is mg. This is also acting vertically downwards. So horizontal distance is what? From where the force is acting to the point where moment is taken. So this one is what? A1. So mg into a1. Similarly what? fc1 is acting what? Horizontally. So distance will be what? Vertical. From where to where? Where the force is acting to the point where moment is taken. So vertical distance is what here? x1. So all the vertical forces I am writing one side of the equation, horizontal forces I am writing one side of the equation. So I am writing here what? mg plus s1 by 2 into y1 plus mg into a1 equal to fc1 into x1. So you can write down this one as mg plus s1 by 2 into y1 is equal to fc1 into x1 minus mg a1. Okay, so this can also be written as what? mg plus s1 equal to 2 gets multiplied and y gets divided, y1 plus minus mg a1. Similarly for second case we will be writing, I am direct writing the. Similarly for second case we have mg s2 divided by 2 into y2 plus mg2 mg into a2 fc2 into x2. Excuse me. So final mg plus s2 is equal to this one. Okay, so let this one be equation 4 and this one be equation 3. Okay, subtracting equation 3 from 4, so we are subtracting this equation minus this equation. So what we are getting, if we are subtracting the both equation, so I can write down this one as mg plus s2 minus mg minus s1 equal to 2 by y2 into fc2 x2 minus mga2 minus 2 by y1 c1 x1 minus mga1. So this and this get cancelled, so we have what s2 minus s1 is equal to this much. Just I am copying it down. So here I am getting this one, s2 minus s1 is equal. Next, stiffness of spring. Stiffness of spring is nothing but s2 minus s1 is equal to what? H into s. So this s is your what? Stiffness of spring. Okay, since I am writing small s. So this is your stiffness of spring. s2 minus s1 into h into s is your stiffness of spring. But what is h? H, we have proof what? H is equal to what? H is nothing but h is equal to r2 minus r1 divided by x. Okay, next, neglecting the obliquity effect of the arm, where x1, that is x1 equal to x2 is equal to x, and y1 equal to y2 into is equal to y. Okay, so when x1 is equal to x2 is equal to x, y1 is equal to y2 is equal to y, when again we are seeing, then what we are getting, when we are taking again moment at point O at minimum position and maximum position, what we are getting is what? So when x1 is equal to x2 is equal to x, y1 is equal to y2 is equal to y. Okay, so we are seeing that same we will be deriving the equation. So here once again we are writing the equation mg plus s1 y2 plus, and we are here neglecting the weight of the ball, so here is equal to fc2 into your x. Similarly, this is for minimum position, and for maximum position this one is mg plus s1 divided by 2 is equal to fc2 into your x. This one, sorry, this one is fc1. Okay, that implies mg plus s1 is equal to your 2 into fc1 x. Similarly, here mg plus s2 is equal to 2 into fc2 into your x. Okay, here I have left your distance, that is your y distance, and here also y distance, so this is x by y. Okay, now again we are subtracting this equation. 6 minus 5, so what we are getting, mg plus s2 minus mg minus s1 is equal to 2 into fc2 into x by y minus 2 into fc1 into x by y. So this mg and this mg get cancelled, so we are getting s2 minus s1 is equal to your what? 2 into x by y into fc2 minus fc1. So you know s2 minus s1 is equal to h into s. s2 minus s1 is equal to h into s. So what is your h? H is your what? So what is the value of h? H is what? r2 minus r1 by x into y, this whole into your s. Okay, so what is s2 minus s1? s2 minus s1 is this was 2 into fc2 minus fc1 divided by your what, y into your x is equal to your, this is equal to r2 minus r1 by your x into y is equal to your s. So if you are taking this one, so what we are getting, x into x is your x square, y into y is your y square, and this one is coming down here. So fc2 minus fc1 divided r2 minus r1, and this one is x by y whole square is equal to your s. Okay, so when x1 is equal to x2 is equal to x and y1 is equal to y2 is equal to y, the formula is this one. Okay.